Automated test engines make it easy for project managers, technical leads, and business sponsors to receive true project status information when developers are building data warehouses and other large business intelligence systems. In this short screencast, Saragenic's Chief Systems Architect, Ralph Hughes, will describe the 4 steps required to achieve what we call evidence-based project status reporting. First, a little bit about the presenter.
I'm Ralph Hughes. I help companies build data analytics applications 3 times faster and for 1/3 the cost compared to traditional approaches. I've been in the business for over 3 decades now, serving today as the Chief Systems Architect for Saragenix, a business intelligence consulting firm. I've been an instructor for many years at the DAMA and TDWI conferences and have written 3 books on building data analytics systems, such as the most recent one, which is titled Agile Data Warehousing for the Enterprise.
The driving question for today's screencast is, how can managers find out what's really being accomplished during the development of their enterprise data warehouses or large business intelligence applications?
That's a really good question. Projects such as data warehouses and big data apps take a long time and are really expensive. 1,000 things could go wrong, and many of them are very technical and hard for anyone but the developers to spot right away. Yet management needs to make sure that all the time and expense is adding up to something valuable. Programmers are great people, but they often try to fix problems before anyone notices they exist. That practice leaves managers blind as to whether the project will be completed on time and with all the needed features. Such limited vision about what's really going on with a project should make managers very nervous indeed.
So, is there an easy way to get visibility as to what portions of a development project have been actually completed?
Well, I can tell you what Saragenix consultants do on our Agile data warehousing projects. We structure the project to revolve around an automated test engine so that every morning we get a readout on what's working and what's busted. Of course, this requires a bit more than just installing a test engine. First, you've got to move your team over to test-led development at the project level. Second, you've got to categorize your tests to support the status reporting that you need. Then you can set the automated test engine to run a full test of the application you're building every night. With all that in place, you can then use your favorite BI tool to explore test results in the repository to see your project's true progress towards its goals. Tests that have passed equal work that's completed. Tests that fail is work that still has to be done. It's as easy as that.
Can you tell us a little more about Step 1's notion of test-led development and what that might mean when applied at the project level?
Sure. In following best practices for agility, we have our programmers write the tests for each module before they code it. They then program until the module passes those predefined tests. You get better results this way because developers are forced to think again about their requirements and design before they program. So if test-led development is such a good idea, Saragenix says, why stop at the module level? Why not pre-write tests for each subject area or the entire application? We use a top-down quality planning process where we write those user and system tests for the application as a whole before we begin coding a given sub-release. This practice has a nice side benefit of letting us count the tests that should be passing when each module and subsystem is completed. And those counts then represent the delivery goals for each phase of the project.
In what ways do you categorize the test cases during Step 2 so that they provide insights into project status?
Good test engines allow a team to define a set of tags that they can put on every test case. Saragenix developers usually tag each test we write for the project the module belongs to, the subject area that we're programming, whether the module is in the staging, integration, or presentation layer of the application, the actual component that's being evaluated, and even the programmer that's writing the module. We also tag whether the test is validating an initial load or an incremental load, and even if it's checking on end of month or end of year logic. We also tag whether the test is focusing on normal, good-to-load records or challenges such as dirty data and missing values. Now, with all these tags in place, not only can the team run a specific subset of the overall test library, but managers can use these tags to look at the subsets of results. When the project hits a snag, test suites will start failing, and then managers with a BI tool connected to the test engine can drill down all on their own into a problem area and discover the root cause of the team's challenges, long before the programmers tell them that something's gone wrong. That's pretty cool.
Now, step 3 is to set up the automated test engine to run full nightly testing on the application, right?
Yeah, that's right. With all the user and system tests defined ahead of time, we can configure the test engine to execute a full suite at that level, whether the application is ready for those tests or not. Such test suites usually need to run overnight, of course, especially as the developers start using realistic data sets for development. The test engine will record each night's results in the quality assurance repository, and in the morning, the tests that pass will show up as green on the QA dashboard, and those that failed will be displayed as red.
Then, finally, in step 4, you recommend managers start using a BI tool to uncover their project's progress towards defined goals.
It's easy. You start with aggregate results, you spot an area where the team is struggling, and then you drill into the detail to find out what's really going on. The graph that Categorize uses in its quality dashboard has 4 trend lines. The first one shows the goals for the project. Another one shows the number of tests that have been written and implemented in the test engine. A third line shows which of those are actually running, and then a fourth line shows the number of tests that are passing. When the number of tests passing climbs up to where it touches the line representing the project goals, you know the application is ready to ship. Now, working with trend lines such as these, a manager can click on any one of them to drill down using those tags we discussed earlier. They can quickly discover in this way which components or features or even which programmers are having trouble.
What kind of test engine should these big data analytics projects use to give their managers evidence-based project status reporting?
On Categorize projects, we use a test engine offered by a company called Zuzena, which we really like. Zuzena has test case containers, which we use to declare the tests that should be written. And then it has a test case repository, which contains the tests once they have been authored. A test results repository records tests that the automation engine has executed, plus whether those tests have passed or failed. All repositories are tagged with user-defined categories that let managers, developers, and stakeholders explore test activity by project, subject area, component, or error type. By combining test-led development at the application level with the features of Zuzena, anyone can understand a project status based upon what's happening with the testing. The QA repository becomes this concrete measure of team progress. We call it evidence-based progress reporting and find that it's a lot more dependable than developer statements of what they have or have not finished programming.
Setting up evidence-based project status reporting sounds pretty straightforward. But can you help our viewers who might feel that the benefits of this approach still seem a bit abstract?
So let me give you an example of what it's like to work with Zuzena and a test repository that's been tagged by the characteristics that you're interested in tracking as a manager. In display 1 here, this is the aggregate of, say, the master customer subject area. And what we can see 4 lines here. The purple one is the goals, and the blue line is the tests that we've written and we're executing in the dev environment. The red line are those tests that have been transferred over to the system integration test environment, and the green line are the SIT tests that are actually passing. So if we look at this, we say, okay, our team was defining quite a few tests, for Dev and SIT, and we were approaching the purple goal line there towards week 17. If we could get all those tests to pass, we'd be very close to shipping this application. But then we noticed the green line, and we're saying, you know, there's suddenly many fewer tests passing in this master customer subject area. So why is that? So that's when you click on the green line and say, show me more about what's going on with this subject area. So I choose to drill down by architectural layer, and first thing I look at is, well, is the data getting staged okay? And I see here in display 2 that the landing zone tests seem to be passing well enough. So it's not there. That's not where the green line started heading south. So I back out and I click back into the integration layer, and yes, there I can see it. That green line has plummeted in weeks, starting with week 16 and 17. So now I got to ask myself, okay, that's a big integration layer. What component of it is failing? So I start drilling into the other tags, such as what kind of component types or column types I have, and then I see here in display 4 that it's the derived columns for the integration layer that have stopped passing, that have started to fail more tests. And I say, okay, now we've tagged the derived columns by what theme they're calculating. So is it the global customer tagging calculation that is going wrong? I click into that here with display 5. I say no, those are doing just fine. So I back out and then I drill into the derived columns for customer scores. And here in display 6 I can see, yes, it's those customer scoring columns that are failing. So now with just a few clicks, as a manager watching the project from a distance, know that there's a problem going on, and I know where it is approximately, and actually with quite a bit of detail. And now I can go down to the project room and ask the programmers, hey, what's going on with the customer scoring columns, and what is it that I can do as a manager to help you get past this hurdle?
In this screencast, a leading expert in Agile data warehousing has described an easy way for project leaders to obtain accurate project status information on a daily basis using an automated test engine. The first step, he suggested, is to require your developers to write their system and user tests before they start programming each sub-release. Step 2 is to tag those tests with the categories you need to understand project status. Categories such as application architectural layers, module names, and the type of errors the components must adapt to. Step 3 is to put the test automation engine in place. Sterigenics uses the Zuzena brand test engine on its projects because Zuzena is built to provide goals and results in a form that managers can easily explore and understand. In step 4, managers begin using their preferred BI tool to look through the daily test results, drilling into areas where tests are failing so that they can discover where additional support will help the developers overcome the challenges they face. Thank you for watching this screencast. There's much more to learn about both test automation and other development techniques that can rapidly deliver world-class data-driven applications. Contact Sterigenics for more information, and good luck with your projects.